safe food process. And if you can see that present aquaculture system in Bangladesh, we are seeing the practicing the antibiotic and disinfectant is drastically increasing, and that happened 30 to 40% different antibiotic already found in Bangladesh, and 73% farmers didn't know actually the residual effect and what's the actual impact in the aquaculture system. But they have no opportunity to do things because they have no alternative systems. So here we are actually the study we are doing. So actually how can we remove this process in aquaculture sector and how actually introduce the smart aquaculture system. And that's how we are introducing an in-pond research system. It's actually when you actually take your table in a fish, you think about it. It's actually traceability. Yeah, the farmers actually culture this, and the lots of heavy metals and disinfectant different perspectives already regularly using. But in-pond research system, you can think it's a river-like environment we're introducing in the pond, and it allows already 4 to 5 times fold specifically in sustainable perspective or in growth performance. So what's the actually philosophy? The philosophy we introduce. In traditional culture, there's three major problems. First problem, there's ammonia, and because of features of discrete oysters in the pond, that's the main problem. And second of all, the continuous aeration, that means lack of oxygen or dissolved oxygen, and the water quality parameters degradation, the main problem in traditional aquaculture system. So we give the solution, the three types. We ensure the fixed Raceway, we give the continuous flow, and third of all, is a white water effect with continuous water flow and regular oysters removal process. You can see our mother site in Fishtach, Aquaculture Limited. We are culturing this Iprs system is already just 3 cells with already 300 decimal pond. That means we all just use 2 to 3% pond specific space for producing high quality and high valuable fish species. So our main objective actually how in-pond resource systems and can regulate the water quality and monitoring, and already also I will discuss about the good performance. So this study is conducted in 300 decimal in a pond, and 2 or 3% 6 decimal pond part of pond used in the cell, the 3 cells you can see in 100 day trials, and we did the 3 specific cells which consisted 220 meter cube cell size, and we stocked 40,000 Nile tilapia in each cell. That's a huge milestone comparing to traditional aquaculture system. And you can see the structure. There are different structures, some confinement gate area and mechanical solid waste removal form. You can see the second picture. I can show you the total experimental site. There's a 3 Raceway, specific where fish actually cultured, and total fish area that's not empty of fish. And there is some white water in it. We can say this specifically blowers who are responsible for giving the flow to the total pond environment, and specific 3 air lifter who is setting to the specific consignment gate, increasing more water flow, like making the river line. And specific, we can say a buffer wall settings to introduce or more to circulate the water is more increasingly, and that's the total cell. We can see the 220 meter cube cell and a specific oyster zone after the 3 cells. So total principles, we do some dissolved oxygen management with air lift pump and secondary blower, and the total pond acting as a specific biodegradation pond, and we do checks continuously here. So you can see just some air lifter who actually introduce the more oxygens and more water flow in this system, and the main principle is solid waste management we did, and we did some solid management. We can say this is the acquired zone. So after the cell, there's a state of acquired zone, and this becomes the acquired zone. So in acquired zone, some mechanical concept we have already introduced, and with these factors, we have just continuously removing the total solid or wastes we have already did. So yeah, that's the acquisition zone and transferring to the outside. So it's a total pond bioremediation because of a large pond that's totally used as a biofilter, and they also control the phytoplankton biomasses, and bottom aeration always improves the specific flow, and so it's a total pond bioremediation you see. And outside of pond we also did some stocking some planktivorous fish which are maybe not using some artificial feed. So total feeding management is as usual feeding management, 28 to 32% protein and 3 to 4 times a day, and adjusted with our body. And we continuously, in a daily basis, morning and afternoon, we continuously recorded the water quality, different parameters, and we did data collection is total 3 months culture, the 200 day culture systems, and 3 partial harvesting were taking place. So you can see the result, the total specifically ammonium ion It's totally instable condition in total culture area. There's a 200 data we have already managed, and the pH level, the more importantly, is 7.2 to 8. It's continuous in total 100 days cycles. That's a milestone compared to control pond, because control pond actually pH fluctuation is also a challenge. And the total ammonia value is less than 0.02 continuous time, and total whole cycle, and total alkalinity, and total dissolved oxygen. That's the important part in this segment. Is always higher to 7. And it is the total final result: pH, ammonia, and dissolved oxygen, alkalinity, always in the standard level. That's why specifically fishes don't feel any types of stress or any kinds of disease cases we have found in total culture area. You can see the survivability rate in 3 different cells, and specific production comparison. We already produced 9 ton in per cell, specifically 220 meter cube cells, and specifically the super feed conversion ratio. And the final result, we stocked 40,000 in each cell, and after that survivability rate and final body weight, we did already 9.2 ton fish produced in one cell, and average 3 cells we produced already 45 ton. That's 4 to 5 times better and greater compared to control pond. So it's not only that we can produce the same food, we also produce actually economic viability comparison. So first actual discussion in part this, we see the pH, dissolved oxygen, and ammonia and alkaline level is total standard parameters that indicate the total pond ecosystem was very good in conditions, and that's the process is directly correlated with their high yield and the efficient axial and the consistent growth performance. So we can find out it's actually low physical stress and the environment we found out in the total